Okay, solving optimization problems. At the Skywalker Moisture Farm on the desert planet Tatooine, there are 24 moisture processors, with an average yield per processor of 300 qubits of moisture. Research conducts at Mos Eisley University concludes that when an additional processor is used, the average yield per processor is reduced by 5 qubits. Help Owen and Buru Skywalker find the number of moisture processors that will maximize the number of qubits. So the first thing we want to do is identify the variables in this problem. And first is the number of moisture processors, which we're going to label as X, and the number of qubits, which we're going to label as N. Then we want to identify what the domain could be. For this question, we're going to do -24 to 60. -24 because that would bring the moisture processors to 0, which would yield 0 qubits, and 60 because every time you reduce 50 qubits 60 times, that will also bring you to 0 qubits of moisture when we want to maximize the number of moisture. So those are our constraints, how far we can go. Next, we're going to create an objective equation. So we are going to do 24 plus x, x being the number of moisture processors, because every time we add one moisture processor, we're going down 5 qubit units. So we're also going to do 300, which is the initial, minus 5 times x, because every time you add one x, it's going to bring the total number of n down by 5. Next, we are going to take the derivative of this equation. 24 plus x times the derivative of g, which would be -5, and then 300 minus 5x times the derivative of f of x, which would be 1. Then we expand that out, which is this, and we set it equal to 0 to find x. X ended up being 18. Now, 18 is one of our options, along with the domain. So we're going to plug in every one of these and see which yields the most amount of qubits. When you plug in -24 over here, you get 0, multiply, and you get 0 over here. When you plug in 60, you get 0 over here, and multiply, and you get 0. Then when you do 18, we end up getting 8,820 qubits, making 18 the most, making it the best option for the number of moisture processors to add, because that's how many qubits it will yield.